All right, so now let's increase that compounding frequency. So we're going to consider the concept of increasing the compounding frequency without bound. So, we start with a is p times 1 plus I to the n, and I is r over m, and n is that m times t. So that's just simplifying the formula here, and that gives us that. Now, if we multiply the exponent by r over r, which is just 1, that gives us this following thing, okay? Now, if we say, well, let x equal m over r, then 1 over x is r over m, then that gives us this here, x times r times t. And so using law of exponents, so if we go back and try to remember what that is, and again, when we have that r over m, that's 1 over x, we have to replace that here, and so we replace that and that. Then a to the x times y is equal to a to the x to the y. And so then what we can do is we can take this and pull it out, and then it's raised to this here value, the RT. And so then we have, at this point, the following. Now, as the number of compounding periods, m increases without bound, guess what? So does x, okay? And so when x increases without bound, the expression 1 plus 1 over x to the x gets close to the irrational number e, which is roughly 2.7183. So this is what we're going to go to. We're ending up with an e value instead of what we have here. And so this piece inside here is going to get replaced with, instead of a nasty looking 1 plus 1 over x to the x, we're going to replace it with e. And so that's going to give us e to the RT. So that's what our limiting value is going to be. So that's going to be our continuously compounding interest formula. And, the way to remember that is the future value is equal to PERT, PE to the RT. So that's going to be a way to remember that one. And so if we have $1,000 at the 8% interest for 5 years, and we want to figure out what it is continuously compounding, we get 1491.8247 or 1491.82 if we don't round it. And from previous numbers, what we had, I forget what we had back here, but we had, we had 1489.85 for compounding. We went to monthly, we didn't go to daily, but we got up to that. And so, we're now only at 1491. So we went from 89 to 91. And so we missed the daily, but that's not a huge number jump, but that's the best you can get is the continuously compounding. Okay. All right, so this is the continuous compounding interest formula. So if principal P is invested at an annual rate R expressed as a decimal, compounded continuously, then the amount A in the account at the end of T years is given by A equals P e to the RT. Again, the best way to remember this is PERT, okay? All right, so we have here, what will an account have after 2 years if $5,000 is invested at an annual rate of 8% compounded daily and compounded continuously? All right, so that's going to be what we're looking at for now. And so when we do that, what we have to do is we have to remember that there's 2 different formulas here. So compounded daily, so that's going to be A is equal to, and we're going to have $5,000 for the P times 1 plus, and our rate is 8%, so 0.08. And we're going to use 365 because they didn't say it's a banker's one. And then that'll be 365, and T is going to be times 2. Oops, 2, not T. And so now if we type that into our calculator, that will give us compounded daily. Now, what instead, if we wanted to do compounded continuously, well, A is equal to, remember, A equals PE to the RT, and so P is 5,000, E to the 0.08 times 2. Okay, so now we've got 2 calculations to run. All right, so let's clear that out so we can remember. And so we had 5,000 times 1 plus, we had 0.08%, I believe, if I remember, then 365 days raised to the power 365 days times, and that was 2 years. And so 5867.45. So that's 5867.45. Okay, now let's do compounding continuously. So let's go back over here, and this one's a lot easier. So it's just principal 5,000. Now you have to know where to hit your E button. So it's second ln, and then we have R, which was 0.08, times our time, which was 2, and we get 5867.55, 10 cents more. All right, so 10 cents more, that's 5867.55. So daily is usually the best we can do as far as compounding, because you don't want to do hourly and things like that, because that gets to be some nasty numbers. But from daily to continuously, we're only going up by 10 cents. If I can write correctly here. Maybe I'll erase that and make it a little clearer. So only going up by 10 cents when we do the daily to the continuous. Okay. And I put this on here in case I needed extra space, but we don't need that extra space. So let's stop there and then we'll come back for some more.